Okay, good morning, everybody. Sorry for opening the session a couple of minutes late. There's still one or two people waiting to join, but we'll start with the introduction. Fairly busy session today. Lots of you attending. I'd like to welcome Terry O'Connor from GDPS Development, who's very kindly agreed to present whilst he's on his holidays in Cornwall. It's probably raining anyway, so he's not missing much. Terry tells me that he's got a fair amount of material, so I'll actually keep the introduction pretty short. Usual process for questions, please put them in the chat room and I'll monitor them and ask Terry if it makes sense during the presentation, because he said he's happy to take questions. Otherwise, we'll get to them at the end. So with that very brief introduction, let me hand straight over to Terry. Terry, thank you very much.
Thank you, Nigel. Okay, as Nigel says, I work in GDPS development, largely on the replication solutions. And in recent years, or recent 18 months, 2 years, focused increasingly on logical corruption protection, which is largely the scope of this session this morning. So I think really one of the things which seems to be quite evident is the growing number of cyber attacks that we're seeing in the business world. And I think the question now, well, the question is really, it's not a question of if a business will be the victim of a cyber attack. It's more likely now to be a case of when will they become a victim of a cyber attack. And I think that's evident from the response that we're seeing to logical corruption protection in terms of the GDPS solution. But before we actually talk about the actual logical corruption protection solution that is delivered with GDPS, I think it's worth just reflecting a little bit in terms of where GDPS came from, its origins, if you like. So it was largely developed to address kind of what are commonly known as the RTO and the RPO, the recovery time objective and the recovery point objective that clients stipulate in terms of the availability of data, either in their local region or in a multi-region disaster recovery solution in their recovery region. And GDPS was very good at combining a range of functionality, disk replication, sysplex, hyperswap, those types of functions married together, providing a high availability solution and obviously a disaster recovery capabilities. But I think with the advent of cyber attacks in the marketplace, it's quite clear that those technologies alone are not going to meet the requirements, the ever more demanding requirements clients are placing on GDPS or IBM in respect of protecting their data. And it's, I think from that spun the LCP story, our ability to frequently take point-in-time captures that are then available for restoration back into production in the event that the data that underpins your business becomes contaminated or corrupted. So if you look at the solutions we had the Metro solution, which was just the two-site HA type based solution. Then that went to the GDPS Global for disaster recovery, and then a combination of the two to give you GDPS Metro Global 3 and 4 site, which is, I think, where a lot of our clients today sit in that third column, if you like. And then obviously extending that further with software replication and workload switching, we have the GDPS continuous availability solution. So there is a portfolio of products that sit there today protecting data. But what's quite clear is that if one of those copies becomes contaminated, then it's very quickly replicated to the second, the third, or the fourth copy. And consequently, LCP is there to address that and say, how do I back out those contaminated updates? So Oops. So what is GDPS logical corruption protection? Well, it's a standalone feature that you can install. It comes in two varieties. They're called an LCP manager. So we have an LCP manager for Metro Mirror and an LCP manager for Global Mirror. So they're the two underlying disk replication solutions that LCP is kind of built upon, if you like. So you can either run a Metro Mirror LCP manager or a Global Mirror LCP manager. And those managers are essentially responsible for taking periodic captures of your production data using one of two technologies today. That's either flash copy or safeguarded copy. And those captures can subsequently be used for a variety of purposes. So you can have catastrophic failure or corruption, and in which case you might wish to restore the entirety of your business workload back to a specific data point. Or you might want to use it for forensic analysis. You want to drill down and understand precisely what happened, how it happened, and what data it is that you might need to finally recover to back out the corruption or the contamination. And then obviously surgical is simply how do I extract that data from the backup and restore it back into my production environment. What also is becoming more and more the case or required is this notion of a validation engine. So this is something that's currently underway in terms of the development item, in terms of using the technologies within LCP to build what we call a cyber vault. And that cyber vault will essentially be LCP's capability to take frequent captures, and from those captures to recover them, and those recovered captures could then be IPL'd from using a recovery system. And then from that IPL'd recovered system, we could then drive a series of data validation processes. And I think we're looking at three kind of tiers of validation. So there's just the standard infrastructure validation. Then there's the system level validation, which is looking at does the middleware come up? Are the indexes true, and is the integrity of those indexes for DB2, IMS, etc. are they valid and clean? And then there's obviously a third level, which is user validation, which requires obviously more input from the client to decide how do I actually validate my data to ensure that the data that I have been capturing is in fact good. And all of that information that would be then kept in an audit log within GDPS. You can view that to say, yes, these backups at these times and these dates are good and valid for recovery purposes. So that's validation. And then finally, the ability to take a backup and then offload it to another media platform such as tape. So I think that's where GDPS is trying to fit in with respect to giving the capabilities for catastrophic, forensic, surgical, validation, and offline backup capabilities. When designing LCP from a GDPS standpoint, the key elements, I think, were one, granularity. So we've got to be able to take multiple captures, kind of on a consistent kind of interval basis. And the reason we need to obviously take high frequency backups is the more backups we have, if we then have to use one of those backups to recover our production environment back to a given data point, the more backups we have, the more frequent they're taken, the data loss between recovery from one of those backups is minimized. So it's, the more frequent they are, the less data loss we have should we need to recover from one of those backups. So granularity is absolutely key in terms of LCP execution. The other thing is clients want to be able to ensure that the cyber vault or the LCP solution is isolated from their production environment. So if the production environment is 2 copies, 3 copies, 4 copies, they don't necessarily want to capture copies directly from those instances, copy 1, copy 2, copy 3, copy 4, into a disk subsystem that is used for one of those copies that support your production data. So in some cases, they'd rather have that data externalized on a different disk subsystem. In other words, an air-gapped type approach. So LCP provides both what we call virtual isolation, which we'll look at in a second, and physical isolation. So physical isolation is where the data captures are on a physically isolated disk subsystem. So they are distinctly removed physically from where the production data is resident. So LCP needs to be able to deliver on that and provide the users who want that kind of high level of isolation, that they can use LCP to achieve that. And then finally, the immutability. The copies that we take, especially with safeguarded copy, those copies cannot be vulnerable. They have to be secure. We cannot have host access to those copies in a way that could compromise their integrity or contaminate them. So immutability is key. So there is no way from a ZOS host that you can actually compromise the integrity of the safeguarded capture. In terms of what does LCP really look like in terms of the building blocks or the anatomy of it, I think it's, if we look at this picture, we can see on the left-hand side what is our production data, if you like. So here is our production data, and we can take captures of that production data. And the captures are taken to what we call a copy set. So a copy set, which is that middle column, can either be flash copy or it could be safeguarded copy. So it's up to you how you wish to deploy LCP. You could use either flash copy or safeguarded copy, or you could simply use a combination of the two. And that's where we have this kind of interval of take a capture from production, and it's there available for those various uses that we outlined before in terms of forensics, validation, surgical extraction, etc. So we have this idea of the continuous capture process, which is driven today by the user in terms of the frequency and the method by which to schedule those captures. And then we have the ability to recover those captures. So when we want to recover a capture, it's essentially identifying the capture that we want to recover and then recovering it to a different copy set that we call the recovery copy set, which is on the right-hand side. And in that off of that recovery copy set, we can then IPL a recovery system and use that data for testing, for validation, for analysis, whatever purpose the client sees fit. So we have the capture on the left to the copy sets in the middle, and then the recovery to the copy sets on the right. Now, it is feasible for clients to actually, in the event of a cyber event, they could simply recover to the recovery copy set and then IPL their production system from that recovery set and bring, that's it, production's now back up and running. In the event of doing that, it would then require a full copy back to the production site, if that's what's required. And we'll look later on. In the pop GDPS DR, could a mainframe emulator be used to test your GDPS DR test backups? I think you'd have to expand on what the definition of a mainframe emulator is, but we can maybe look at that towards the back end when you say, could it be a mainframe emulator for the DR testing? But I'm not opposed to any suggestions if it kind of provides greater flexibility, but maybe we can discuss that towards the back of this session. So, as I say, when you do the recovery, you can either bring production up off of that recovered copy set, or you could then ultimately do a full copy back into the production data center, if that's how you wish to accomplish it. With some of the functionality that will be delivered, in fact, at the end of this month, we can actually incrementally restore data back to production from that recovery copy set. For flash copy today, we can take the copy set in the middle column and directly restore it back to the capture source. So if you think about it, we have capture, we have the targets of those captures. Those targets can then be recovered and then subsequently restored. But if you do the subsequent restore today, that's a full copy. Or you can simply take a capture and then restore that directly back to the capture source. So there's a variety of different methods that can be deployed in terms of kind of how do you get data back into production. We mentioned this idea of virtual versus physical isolation. On the left-hand side, we have a picture of what we call a virtual isolated model. So to simplify the picture, we've adopted a Metro 2-site solution. So we have simple synchronous replication from RS1 to RS2. And in this picture, we've, on the same subsystem that is hosting RS2, we've configured a recovery copy set and up to 11 flash copy sets, and also provisioned safeguarded backup capacity. Now, in this picture, we've elected to illustrate this as having a complete capture environment configured via RS2. That could be instead configured via RS1, or it could in fact be configured on RS1 and RS2, such that you take captures both at the replication site 1 and the replication site 2 sites. So it's entirely up to you with a virtual isolation solution where and how you wish to configure the capture capabilities of LCP. In terms of taking captures, in this particular example with Metro Mirror, we need to be able to establish a data consistency point, which is the point at which we drive the capture itself. And to accomplish that, there is in fact a performance impact, if you like. It's a small impact, but there is a user impact time as we serialize within the control units to establish a consistent data point, which then represents the captured data. So that serialization essentially can, I mean, in a very large, like I say, a 12,000 pairs, we're seeing with safeguarded less than 1.8, 1.7 seconds of user impact time for 260 LSSs with 12K in terms of number of devices. So it's not too different in a way to what you would maybe see with, say, a freeze within GDPS today. So if your workload is not that kind of sensitive to those types of impact times, then you could conceivably look to adopt a virtual isolation model whereby you take captures directly from your production replication site 1 and or your production replication site 2. So with a virtual isolation model, there is some consideration in terms of performance impact, and obviously the more backups you wish to take, the more frequent these impacts will occur in your production environment. The other thing obviously is that the captures that you've taken are actually hosted in the same hardware, the same disk subsystems as the production replication site 1 and replication site 2 data. So if those sort of things are unacceptable in your environment, then typically clients will consider adopting a physical isolation model. With physical isolation, we're essentially creating an air gap between the production data and where the CyberVault, the LCP data, is going to be residing. So in this example, we have, again, our standard Metro Mirror 2-site environment, but we've now got a cascaded global mirror leg off to what is a separate disk subsystem, the RS3 disk subsystem. And in there, we could configure the recovery copy sets, the flash copy sets, and the safeguarded backup capacity. Now, in this model, there isn't any impact to production because the serialization that needs to occur to get the data consistent point is on RS3 and not on RS1 or RS2. It also provides physical isolation in terms of the disk subsystem for the CyberVault versus where production data resides. So low performance impact, greater level of isolation, and we're seeing increasingly a number of clients adopting this type of model for their Metro solutions or their MGM 3 and 4 site solutions. We talked about restoring data back into production. Today, you cannot directly restore a safeguarded backup copy, which you've captured in this example from RS2. You cannot today restore that directly back from the backup, the capture that you take, directly back to the capture source, which in this case is RS2. That isn't something you can do today. What you can do with this APAR that will be targeting to close at the end of this month, PH 37131, what you will be able to do is take one of those captures and run a process whereby it gets recovered to the recovery copy set and then incrementally restored back to, in this example here, RS1. So at the end of this month, you should be able to take your safeguarded captures and restore them directly back into production in the event of a cyber event which warrants your data compromised. So using this technique here, where we take the capture from, in our example, in this case is from RS2, we then recover it to RC1 or RC2, whichever recovery copy set that we tag as the target for the operation, and then we will subsequently incrementally restore that data back to RS1. So following the recovery, the user can bring their systems up on that recovery copy set just to validate that actually the capture that they're going to ultimately restore back to production is in fact the correct data point, and it has actually all the data requirements necessary to regress any updates that are deemed as part of the corruption that you want to regress. So as I say, at the end of this month, incremental restore back to production for safeguarded copy sets. In terms of this safeguarded repository, if you like, this backup capacity, for each volume that is protected via safeguarded copy, each volume can theoretically, the architecture today is there's a limit imposed on it of 500 captures. So you could, on paper at least, have for each production volume up to 500 data points, 500 captures associated with that volume. Now, that's an architectural limit today. We wouldn't obviously encourage people to have that level of backup inventory. I mean, if you have to restore from one of those, obviously it's you'll see in subsequent files, we have to go down that data stack to recover that data back to production. And the deeper the stack, the more data we have to restore. And I think realistically, kind of clients won't be trying to go back 500 captures to back out data that's been contaminated via some cyber event. For flash copy, we said that in this example here, we have a standard Metro Mirror 2-site replication model, RS1 to RS2. And we can take captures from the RS2 to one or more flash copy sets. So in fact, we can have up to 11 flash copy sets configured. So you could have theoretically up to 11 active captures in terms of data points that are potentially restorable back to production. So if we had a cyber event on our RS1 to RS2 replication leg, we could look at any one of those 11 data points and say, yes, please, let's restore that back to production. And this you can do today, restore straight from whatever one you tag back into production. You can also take captures from RS2 directly to the recovery copy sets if you desire. There should be a line on here indicating that, but it's not there, I'm afraid. So you can take captures directly to the recovery copy sets, and likewise you can directly restore those recovered the captures from those recovery copy sets back to production. So for flash copy today, you can restore anything back to the RS1 or RS2, and you can recover any one of these flash copy sets out to the recovery copy set. Okay. So the recovery copy sets are really there to facilitate testing or validation, or any other use that you feel that you'd like to exercise these copy sets for. So you can basically take any of the captures, be it flash copy or safeguarded, take that capture and then recover it to one or more different recovery copy sets, and then IPL a recovery system from that recovery copy set and perform whatever action it is that you wish to use that recovery copy set for. So the total number of flash copy based copy sets, which is a mouthful, but the flash copy plus the recovery copy sets, the total number of copy sets is 12. So you can use that in any, 11. You can use that in any combination that you like. So you could have 8 flash copy and 3 recovery, or you could have 6 flash copy and 5 recovery, or whatever, whichever way you wish to configure it. But the maximum number of flash copy sets that you can support within an LCP environment is 11, using any combination of those two. So you have, as I say, this flow, take the capture, back here, sorry. Take the captures to flash copy sets or safeguarded copy sets. You can restore those directly back to production, or you can recover them to the recovery copy sets and do other analysis or validation, and then subsequently restore those back to production. Okay. From an LCP perspective, I think 2 key things that the user needs to decide upon. One is the frequency of the backups. So when we use safeguarded backup as an example here, the more frequent that you wish to take backups, the more kind of data you're going to be capturing, and therefore the amount of capacity required to support those captures will increase. So if it's a high frequency of backup with a long retention period, then you're going to be having to provision a lot more backup capacity to host all of those backups that you wish to take and retain. So we find that kind of clients are sitting in terms of frequency, usually 4 to 6 hours between each backup. That's a very kind of common landing spot today for the backup interval frequency. That's not to say that there's clients who have a more demanding backup frequency, and there's some who have a less kind of demanding frequency in terms of the backup capture process. And then obviously, how long do you want to retain that backup? So when a backup's taken or a capture's taken in LCP, it's part of a profile that describes the characteristics of that backup in terms of its retention. And so you can specify retention in minutes, days, or hours. And LCP will only allow that backup, that capture, to be released when the retention period has elapsed. So there's this concept of a capture that's either expired or not expired. If it's expired, then it's eligible for release. And if it's eligible for release and it is released, then the space used by in the backup capacity is therefore released also. So housekeeping is key in terms of ensuring that you keep a sufficient amount of backup capacity to retain the number of backups that you wish to retain, but also to support the frequency at which you wish to take those backups. What data resides in each safeguarded backup and how much storage needs to be set aside to do this? Okay, I think the next file will kind of describe that, hopefully. So when you define safeguarded backup capacity, what you essentially do is, for each of the volumes that you wish to protect with safeguarded backup, you would have to, via the 8K interface, define a backup volume. And the backup volume is essentially a theoretical piece of storage which you configure with what we call a multiplier. So you would say, how much capacity do I require for the number of backups that I need to retain in my production environment? So if your production volume is a mod 1, you could theoretically say, well, I need the equivalent of 2 mod 1s to support the backups that I want to retain. Now, obviously, each backup is not a full copy of the volume. It's only it's the delta of what's changed since the last backup. So it's just essentially an expanding log of backup data, if you like. So maybe if you're dependent on your sustained data rates, update rates, and the frequency that you wish to take the backups, having a multiplier of 2x might be adequate. So you could, maybe be able to retain 3, 4, 5, 6, 7, 8, 10 backups with a theoretical capacity of 2 times the source volume. In some installations, based on higher frequency with greater update activity rate, then you might find that 2x isn't sufficient and you require more. And we'll see in a minute what that means. So you define the backup capacity using a multiplier. Once you've just take a safeguarded capture of the 100 terabyte, I now need another. No, this is thin provision storage. So it's the 2x is a theoretical limit. It's a virtual capacity limit. We don't pre-allocate that amount of real capacity for a 100 terabyte device. When you take the capture, obviously that first capture is going to be an open capture. We established the metadata to describe that 100 terabyte volume. Subsequent captures then would only be storing the delta from that baseline to the next capture data point. So you're just building on that. So no, we don't require 100 terabyte physical capacity for the backup volume. It's simply a theoretical vertical capacity limit, which is used. So these are all thinly provisioned devices within the DS8000. If the 2x proves not to be adequate, you can actually expand the capacity of the backup volume. So you can go from a 2x. There are tools available on the DS8000 for doing that, but there's also data which we'll see in a minute within LCP, which will show you how much of the virtual capacity you are using for any given volume. So you would have to understand your data rates of your production environment. You might start off with a relatively conservative multiplier and see based on the number of captures that you wish to retain and the update rate activity that your production environment is using, that you'll see then how much of that capacity is actually being used within the backup volume. We'll see that in a minute. So if you think of this as kind of the backup capacity is essentially just a circular buffer of space within the DS8K extent pool. If you think of the first backup up here, this would have originally been T1, so data point 1, and this would then have been T2, T3, T4, and T5. So in this example here, we originally provisioned an amount of space whereby we could keep up to 5 data points, if you like. So, but we decided that kind of maintaining 5 wasn't sufficient, or we wanted to retain 10 data points. So we decided, therefore, that we needed to expand the virtual capacity for this particular volume from maybe 2x to 4x. When expanding it, we provision another theoretical area for the expanded backup capacity, but that doesn't immediately become available to the LCP capture process. It can only be extended into when any existing backup that gates the use of that expanded area has been released. In other words, it's expired and has now been released and therefore can be overwritten. Because this, as we see, is just the circular buffer. So in this example here, we started off with T1, T2, T3, T4, T5, and then T1 was expired, which meant we were able to release it. So therefore we created T6. T2 was then expired and released, and we were able to create T7. And then T3 was expired and released, and we were able to create T8. So once T8 is created, we now have to wait for T4 to be expired and therefore eligible for release. So until T4 and T5 are expired and released, we cannot extend into the expanded area that we dynamically created when we moved from a 2x backup volume to a 4x. So in GDPS, we have a monitor that looks at your backup volumes. And if you do go through the dynamic expansion process, you will then get on a monitor basis any backups that are the expanded space has not been effectively opened until some of these gated backups have actually been released. And GDPS will identify those gating backups and report those both to the net log and through SDF alerts. So you will see it where an LCP administrators change the multiplier, from maybe going from 2x to 4x, and thinks that maybe they can immediately start to use that space, but only to discover that that space will not become available for use until the gating backups have actually been expired and released. There are a range of topologies that GDPS supports in terms of, or LCP supports in terms of whether it's a virtual isolation or a physical isolation model. And this is pretty much where we are today. So for Metro 2 site, you can either configure LCP with virtual isolation or physical isolation. Same is true for 3 site. It can be either a virtual or a physical isolation model. GM2 site, again, both are supported virtual and physical isolation. And then MGM3 site, we have virtual isolation on the Metro leg or virtual isolation on the global mirror leg, or you can in fact have physical isolation in that model too. And then again, we go on to 4 site, where currently we do not support virtual isolation, but we do support physical. And then there is for MZGM clients, we have virtual isolation on the Metro leg and no physical isolation. So this is, as it stands today, the support matrix for LCP. So looking at those in a little bit more detail, we have the GDPS Metro 2 site, which is with virtual isolation. So that safeguarded capacity or the flash copy capacity could be either on RS2 or on RS1. And then the same would be true in a Metro 3 site solution where with dual leg, you could configure the flash copy or safeguarded backup capacity either on RS2, RS3, or RS1, or all of the above. And as we said, when we serialize to get the data consistency point, we will use the extended long busy. We inject that across the range of devices within the consistency group to achieve the data consistency for the capture, be it safeguarded or flash copy. So there is a potential for a response time impact, user impact in a virtual isolation model where we're using synchronous replication, GDPS Metro 3 or 2 site. If you want to physically isolate in Metro, then it's a case of cascading a global mirror leg from one of these copies here. So in this case, we have cascaded global mirror from RS2 into the cyber vault. And in this one here, we've got 2 global mirrors configured, one from RS2 and one from RS3. Again, up to you to decide. So you could actually be running global mirror from RS1 and RS2. But you know, if we, in this example up here, if we swapped from RS1 to RS2, then we could restart RS2 back to RS1. So RS2 becomes a multi-target primary. It's a primary on a Metro leg, and it's a primary on a global mirror leg. But again, it's physical isolation on on the global mirror leg. So your cyber vault is removed from the disk subsystems that are supporting your production environment. And because this is a global mirror leg, we do the consistency group pause within global mirror to achieve data consistency on RS3, and therefore there is no impact to production when taking the capture on RS3, 4, or in this case 5. Global mirror, again, today we only support virtual isolation on the global mirror secondary. So again, it could be safeguarded or it could be flash copy. But we do not support today, at least, virtual isolation on the GM primary. There isn't any response time impact to production, which is running on RS1 in a GM2 site model. However, what it does mean is that we have an exposure in terms of an elongated recovery point objective, because obviously we need to pause GM to secure the data consistency point to drive the capture, be it safeguarded or flash copy. So no impacts to production, but a slight elongation to the RPO whilst we've paused GM. We can take that type of model and extend it into a physically isolated model. So we can, in that case, we have a Metro LCP manager, which is responsible for looking after this cascaded global copy leg, where we're actually cascaded from the GM secondary into the cyber vault. So again, this case, physically isolated from the GM secondary and the GM primary. So again, though, to establish data consistency on RS3, we need to temporarily pause GM, drain the updates to RS3, take the capture and resume GM. So there is, again, an elongation to the RPO during the pause process. With Metro Global, we have two Metro Global solutions today in GDPS. We have the MGM3 site and the MGM4 site. So in the MGM3 site model, you can adopt a virtual isolation model where you have virtual isolation either on the Metro leg. In this example, we've got it on RS2. It could equally have been on RS1, or it could be on both. And you can also implement virtual isolation on the global mirror leg. So you could, in fact, have all three columns with safeguarded and flash copy provisioning for a virtual isolation model. So if you were to, just like before, if you take kind of captures on the Metro leg, you will see some impact to response time. And if you take it on the global mirror leg, then obviously we're going to pause GM to take that capture. So there is some degree of elongation to the RPO to achieve that as well. If you prefer, you can adopt a physical isolation solution for Metro Mirror 3 site, Metro Global Mirror 3 site. In this case, we would cascade a copy from the Global Mirror secondaries. So we have the Metro leg, RS1 to RS2, the Global Mirror leg, RS2 to 3, and then we have a cascaded global copy leg into the vault, RS4. So again, physically isolated. With this approach, there's no impact on the Metro leg, and there is a small RPO elongation as we pause GM to take the copy, the established data consistency for the copy into the cyber vault. So 3 sites, physical isolation. And finally, there's a 4-site physical isolation model. So for the clients running MGM4 site, we have Metro leg RS1 to 2, the global mirror leg from RS2 to 3, and then in the recovery region, we have RS3 to RS4, and now we have a cascaded global copy leg into the vault to RS5, which again is air gapped. Same sort of parameters here in terms of impact, no user impact for this particular leg, and elongation to the RPO during the CG pause to establish consistency on RS5. So how does GDPS or how does LCP drive these processes? Well, there's a series of new script statements that get delivered with LCP. There is the LCP capture, and you specify the name of a profile that describes, and we'll see this shortly, the characteristics of the safeguarded capture or the flash copy capture capability within LCP for this particular consistency group. But to take a capture, it's simply just execute LCP capture and the name of the profile, which describes the consistency group to be captured. There's also an LCP release, which is to release captures that have expired based on their retention period. So GDPS does not automatically release expired captures. It's the responsibility today is on the user to drive an LCP release script for the profile, which describes a consistency group, and to specify whether they want to just release the oldest expired capture or all captures that are currently expired. So by default, you would just get the oldest capture released, and that would obviously free up space within the backup capacity for safeguarded, or it does a flash copy withdraw if it was a flash copy capture. We also have the LCP recover statement. So if you want to tag one of the captures and you want to recover it to one of the recovery copy sets, then you would use the LCP recover script statement. And then finally, there's the LCP restore. And the LCP restore is the statement you would use if you want to restore a capture directly back to production. Or in the case of safeguarded captures, there is a two-phase approach which requires prepare before you do the final restore. So from a capture flow perspective on a Metro virtual isolation model, what you'll see is what we call phase one, reservation. So it's basically establishing everything that's required within the DS8K to minimize the subsequent time taken to do the capture itself. So we do this reservation, which fires off a series of tasks within the 8K to establish metadata and various other elements to minimize this impact time in what we call the check-in, which is subsequent. So once the reservation is done, we then go into a scan to monitor the completion of the reservation. And once the reservation is complete, we then do what's called the check-in. And the check-in is essentially the point where we take the capture. And it's that which is going to expose any form of user impact time to applications. So this, in the check-in, is when we're actually injecting the long busy to serialize and establish data consistency. And then once the check-in is complete, the long busy is released and the process is concluded. So in this example here, very small configuration, but the actual impact time was 0.1 of a second. In a global mirror type solution, we start off again with a similar thing, the reservation and the scan. But once we've done the scan and everything internally on the 8K is aligned and ready to do the actual check-in, what we then do is we pause the GM session. And once the session has been paused, we then start the check-in. And then once the check-in is complete, we resume the GM session and the capture is concluded. So here we have two kind of key numbers, I suppose. One is how long did it take to do the check-in? It's not an impact time because there isn't any impact with Global Mirror versus the impact time that we have with Metro Mirror. But you do have, in this example here, we have an RPO exposure of just about 5 seconds. So that's the time between the consistency group pause, the check-in, and the session then being restored back to a running state. So the RPO hit in this example was 5 seconds. We mentioned earlier that with safeguarded capture, you cannot today restore back to production. That changes at the end of this month with what we said was PH 37131. So before this APAR was available, it would mean that if you took a safeguarded backup that you wanted to restore back to production, you would have to recover it to the recovery copy set and then do a full copy back to production. with this new support and complementary support within the DS8000 on the 9.2 bundle, with PH37131, what we can now do is what we call a prepare copy, which does under the covers, it's essentially doing a recovery to the RC1 set and establishing a series of bitmaps. And once you've done the prepare copy, you can then do an incremental restore back to production. So you can avoid doing this full copy back to production with this support at the end of November. So from a restore to production perspective, you have this prepare copy phase. So here we restore a profile with the prepare copy parameter. There's a comprehensive series of verification checks performed to ensure that everything that's required for this process to be successful is verified up front. We establish the necessary pathing internally between the recovery copy set and the targets. And we do a series of preparations to create various bitmaps that are required. What does incremental copy actually mean? It means that instead of doing a full copy, so if there was, let's say, let's say the third copy here, if that third copy represented 10% of this data necessitating to be regressed, then the recovery or the incremental restore from here back to here would only be copying that 10% of data back. So it's basically the amount of data that needs to be regressed on RS1 based on the data point that you wish to restore from in the backup capacity. So obviously the deeper you go into your backups, the further back you're going in time, the more data that you need to subsequently regress on, in this case RS1, then clearly the amount of data that needs to be incrementally copied back to RS1 increases proportionately. So this incremental copy is influenced simply by the amount of data that you wish to regress on RS1 based on the backup that you wish to restore from this safeguarded backup. So the restore is simply doing using the bitmaps that were created in the prepare copy to do any necessary failbacks that are then required by the actual restore process itself. And then again, there's a series of phases which are kind of volume verification, setting up the pathing, doing any necessary conditioning of the restore target volumes in terms of changing it from a secondary to a primary, so using failover, and then the failback, which is to do the incremental copy back to the RS1 copy set. This section here is really, I could maybe just do a quick whistle stop unless there's questions, but this is really just going through the panels in GDPS. There's two interfaces, the 3270 interface for the older folk and the GUI interface for the younger folk. So you have a panel here where for each consistency group in each replication site, you can create flash copy profiles or safeguarded copy profiles. You can modify the profiles, delete them, get information about them, look at the captures that you've taken. And I think something which is probably worth quickly looking at is the backup information. So creating a profile is simply give it a name. This is the consistency group. This is the site. What type is it? Is it a flash copy or a safeguarded copy? How long must each capture be retained for? So this can be minutes, hours, or days. What's the minimum interval that must elapse between each capture that's taken? So this prevents people from inadvertently taking more captures than they want to, and therefore consuming more space within the backup capacity. And then the maximum amount of time for a safeguarded reservation before we abort, and the maximum amount of impact time that can be entertained as part of the check-in process. Again, if the check-in time exceeds this value, then the check-in is aborted and the non-busy is released. So you can list the captures that are within each profile. So here's a series of captures. It tells you how many volumes that were participating in it, and a series of flags, whether it's expired, etc. You tag a capture if you want to recover it. So here we're just tagging a capture. So you can see that the tagged flag is now set in this example. So that's tagging a capture for recovery. You can list the volumes that are part of the recovery. So here we see all the volumes that are in this, this safeguarded capture. So this is the sequence number, and these are various flags that you can look at the help for to describe what the purpose of each of these flags are. And how many tracks does this capture represent, or how many tracks in the backup capacity is this capture actually consuming? You can query an individual volume to get a detailed view of all of the captures that exist for a volume. You can see which storage pool on the DS8K this backup volume is being provisioned via. You can see which storage pool on the DS8K the source volume is being provisioned via. You can see the capacity of the source is a mod 1. You can see that the capacity, the virtual capacity of the backup volume is 10x, because it's 10 times the size of a mod 1. So you can see that the multiplier is 10. You can see how much of that capacity we're currently using in both real terms and in percentage terms. So again, you can see it from there. But there's also this one here is the list backups. All of these panels have filtering capabilities where you can filter on volumes that have exceeded certain virtual capacity thresholds. So you can see how many captures have been taken. You can see the size of your volumes, the current multiplier used for each of these volumes, and how much of that virtual capacity is currently being used by each of these particular volumes. And you can see what the oldest sequence number is for any given volume, and then there's a series of other flags as well. You can actually go in and list the storage pools within so this is looking at the storage pool information on the DS8K, so you can see the extent size of the pool, how much of that capacity is usable, how much has been provisioned, how much is available, and what percentage is being used. There's a detailed view of that, which gives you information in binary gig, extents, or decimal gig. So you can get, again, a very good view of the actual usage of the storage pool on the DS8K for each of the various types, for extent space efficient, for safeguarded, overhead, reserved, etc. And then finally, that's it, a list of notable LCP APARs that provide various functions and are mostly closed, with the exception of ones down at the bottom, which are targeting November and Q1 next year. I think, Nigel, that's it.
So the timing is absolutely immaculate, Terry. Okay, so I think there's one question remaining about choosing what to copy back into RS1 from Brett. Sorry,
which one was that?
It's about 1124.
What does incremental copy actually mean?
And there's a second follow-up, which is, so I can't choose what to copy back into RS1 ? Brett, I'll unmute you so that I'll allow you to unmute yourself.
Can you hear me?
Yep.
Okay, so in the incremental, from that PTF, the incremental copy, you said it can incrementally copy up to 10% of that data back.
No. So if we had a baseline where, this is our first backup,
yeah,
and so the first backup, when you take a capture in safeguarding, that capture becomes open, and we have obviously we have to start to record any updates that happen from that point hence. So if we take the second backup at, I don't know, an hour from after the first one, and let's say that the amount of data that had changed between backup 1 and backup 2 was 5%.
Yeah.
So the data now that we would, if you wanted to restore the backup 2, we'd have to restore incrementally 5% of that data back. If the next backup was a further 5% of data, and then the next backup was a further 5% of data again, the deeper you go, the further you go back, in time, you're going to have to copy more data back to production. So in that example, if there was a delta of 5% between each of these captures, and that you wanted to go back 4 captures,
but it's restoring the safeguarded copy backups incrementally.
correct.
Can you choose a data set that's within that copy or that backup or not?
Well, you can recover those. That you can completely recover that data point back to the RC1,
and then choose.
And then you'd extract from there.
Okay.
There will be in the future selective incremental restore back of either a volume, subset of volumes. There are ways around that today, but at this point, most of the operations are aligned at the consistency group level.
Okay. And the other question earlier, when we were talking about assigning storage for safeguarded copy backups,
yeah,
and you said that, you know, if I said if you've got 100 terabytes, would I need another 100 terabytes to take all those 500 copies? And you said no, and I agree with that. So how do you calculate the space that you have to assign to take safeguarded copies based on the change rate? So how do you calculate that change rate?
Well, there is data available via the DS8K and SMF where you can actually take some of these. I mean, I'm not really on that side of the fence in terms of doing the capacity planning for this, but there's data on the 8K that can be used to identify what would be a good starting position. But what often happens is that a client would actually kind of set up with a multiplier, say of 2x or 3x or 4x, and then just observe over the course of a week, kind of what sort of growth are they seeing in terms of the backup. If the actual virtual capacity that you assign for a volume isn't adequate, let's say, for example, that you kind of consumed all of that in some ridiculously short period of time, then internally the DS8K will automatically roll off the oldest backup to release space to create the next backup that you demand. So you would be able to use kind of LCP to see what activities occurred over, say, a 3, 5, 10-day periods, and say, right, okay, I've observed this kind of behavior within the 8K in terms of roll-offs. I could see this kind of behavior in terms of utilization level for virtual utilization level for the backup capacity, and using those as the instruments to kind of size that, plus what you can, as I say, what you can get today from SMF and from the 8K. But there is kind of a methodology behind it, which I'm not really probably best suited to describe in detail. But yeah, it's
okay. Thanks.
Okay.
Okay, so if you want to ask a question, you can either put it in the chat or you can unmute yourself. We are a little bit short of time, so don't dither. Couple of things in the chat. There's a small piece of GSE business. There is a vacancy on the committee for this GSE working group. So if anybody's interested in finding out what's involved, drop me an email. Finally, please remember to fill in your session feedback. I've dropped a link in the chat there. This helps everybody really, and as an incentive for you to do this, there is a prize or some prizes for people who complete session feedback. Very last thing is if you need evidence of attending this for continued personal development or education or whatever, then if you complete the feedback, you can get a certificate from the My GSE part of the conference website. So with that, unless there are any further questions, and I'm not seeing any, I'd like to thank Terry very much for first of all interrupting his holiday to do this, and for a very thorough and detailed look at cyber resilience within GDPS. It's clearly a hot topic, and Terry's given us some really excellent stuff. So Terry, thank you very much indeed.
Thank you, Nigel.
With that, unless there's any questions, no, not seeing any, I'll end the session. Thank you very much for attending, and thank you, Terry.
Thank you very much.
Cheers. Bye-bye.